projects. In this video, we are going to explain about DenseFuse, a fusion approach to infrared and visible images. Introduction. The project addresses the challenge of fusion of infrared and visible images, which entails identifying essential elements from source images and combining them into a single image using appropriate fusion algorithms. This task has been approached using a variety of signal processing methods, including multi-skill decomposition-based method and representation learning-based methods. The project presents a revolutionary deep learning architecture that extracts image features using an encoding network and reconstructs the fused image using a decoding network. Convolutional layers and dense blocks are used to build the encoding network, and the outputs of each layer are used to build feature maps. Finally, the fused image is rebuilt using a fusion approach and a decoding network comprised of 4 CNN layers. Objective. The project's goal is to provide a revolutionary deep learning architecture for fusion of infrared and visible images. An encoding network is used to extract picture information, while a decoding network is utilized to rebuild the fused image. The goal is to use deep learning techniques to increase the accuracy and efficiency of picture fusion. The project also provides a brief overview of relevant efforts in the subject of image fusion. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Software requirements. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following 2 modules. The first module is Upload Visible and IR Image. In this module, we will provide 2 input images, one representing the visible spectrum typically captured using a regular camera, and the other representing the infrared spectrum captured using an IR sensor or camera. These 2 images are the basis for the subsequent fusion process. Second module is Generate DenseFuse Image. The DenseFuse algorithm is designed to fuse the information from both the visible and IR images to create a single fused image that retains the relevant details from both sources. The process involves the following step. Pre-processing. Both the visible and IR images undergo pre-processing to enhance their quality, reduce noise, and make them suitable for fusion. Feature extraction. Features are extracted from both images to capture their unique characteristics. These features can include texture, edges, and other visual cues. Feature fusion. DenseFuse employs a fusion strategy that integrates the extracted features from both images. This is typically achieved through techniques like weighted averaging, gradient-based fusion, or deep neural network architectures. Image reconstruction. The fused features are used to reconstruct the final fused image. This involves combining the relevant features to generate a cohesive image that highlights important information from both the visible and IR domains. Post-processing. The final fused image may undergo post-processing to further enhance its visual quality, contrast, and overall appearance. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the IV images in which we have the images which we will use during the execution of the time. This is the model folder. This folder contains algorithm information. These can be loaded into the project code during runtime to utilize the train model. And this is the test images in which we have the test images which we will use during the execution of the project. DenseFuse, DenseFuseNet, Encoder, Fusion Edition, Fusion Normal, Generate. These are the Python files which we have used in the main code for the execution of the project. This is run.batch file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload Visible and IR Image to upload the image. I am selecting sample 4. Open the folder. We can see that the sample 4 is loaded. Now click on Generate DenseFuse to generate fusion image. So here we can see the In above screen, first image is the infrared image, and the second image is the visible image, and the third small image is the generated fusion image. And in third fusion images, we can see two cars and other features little clear compared to infrared and visible image. We can test other sample images also. Now close the image. Let us select another image. I'm selecting the sample one and open. Click on generate DenseFuse image. So here we can see that this is the infrared image, and this is the visible image, and this is the fuse image. So in fuse image we can see a house and a car little bit clearer compared to the visible and the infrared image. Close the images and exit the GUI. And the final conclusion of the project is, the project concluded that the suggested deep learning architecture based on CNN and dense blocks is effective for fusion of infrared and visible images. The network is made up of an encoder, a fusion layer, and a decoder, and it employs a fusion technique to merge feature maps obtained from source pictures. The suggested method is evaluated using both subjective and objective quality indicators, and it beats existing methods in terms of fusion performance. The project also shows that the proposed architecture with appropriate fusion layers can be used to various picture fusion challenges such as multi-focus image fusion, multi-exposure image fusion, and medical image fusion.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.